Alright, so now we're starting chapter 2. This is proofs, where you, figuratively speaking, do arguments and how to prove things or disprove things. Okay, so starting in chapter 2.1, we're looking at conjecture and counterexamples. And again, make sure that you have a look at all the new vocabulary. Inductive reasoning, for a start, is how do you arrive at a conclusion. A conjecture is basically having an educated guess, etc., etc. All right. Now you can get it from patterns, or you can get it from numbers or words. What will be the next pattern? What would be the next? What would be the next word? What would be the next number in the sequence? So that's basically what it is. Okay. And then from that, what you do is, so for instance, in example 1, you've got times. You go from 8:30 to 9:45, from 9:45 to 11. You need a minimum of 3 to be able to make your conjecture. Okay, so if you think about it, to go from 8:30 to 9:45, there are several ways of doing it. So in this case, you're adding 1 hour and 15 minutes to the previous, so 8:30 plus 1 hour and 15 takes you to 9:45, etc. Make sure that pattern goes all the way through, and then finally you come to 12:15, and what you're after in there is what would be the next one after 12:15, so that will be 1:30 p.m. So that's using time, all right? Let's have a look at what you get also in step 2 when you've got patterns. And as you can see, you are adding a bigger square each time. So the next pattern will be 5 of them. Then obviously the final one, which is this step here. Okay, we're looking at numbers. How do you go from 4 to 10? How do you go from 10 to 18? How do you go from 18 to 28? So you can see that you can see whatever the next pattern is. As you can see, you're going up in that one, so you add in 6, 8, 10, 12, so you're adding 2 more to the previous number, okay, or the difference. Okay, so how does these conjectures work? Well, let's have a look at a couple of these. So let's have a look at number 1. So we start off at $4.50. $4.50, the next one is $6.75, the next one is $9. So whatever is the first difference, it needs to be similar. So from $4.50 to $6.75 is $2.25. Okay, I'm not putting the dollar sign, I'm just doing $2.25. If you add $2.25 to $6.75, what do you get next? You get your $9, all right? So, and then what you've got to do is use a conjecture to find the next one. If we're adding $2.25, and we know that's right, $9 plus $2.25, so the next one will be $11.25. All right, so we're looking at dollars. Okay, I'm going to skip a few. Now let's have a look at number 5. Number 5 is a typical example when, if you think about it, it's like a sequence of numbers. So 3 is the first one, the second 3 is the second one, the 6 is the third, etc., etc. But you need to go back to the 0. What did it start? Well, you don't know where it started, but let's assume that you start at 0. So from 0 to 3, you've added 3. Okay, 3 add 6 makes 9. 6 add 9 makes 15. So what you're actually doing is you are actually adding. So it's the 2 previous, okay, so it's whatever the 2 previous elements are. Okay, so if you had 9 and 15 together, you get 24, all right? So make sure you sort of realise where you're going from before you go to where you're coming to. All right, so now let's have a look at example 2. What it's asking you here is make a conjecture about the value or geometric relationship. List or draw some examples that support your conjecture. In other words, you'll make an educated guess. So what's happening? So the question is the sum of 2 odd numbers. Well, here they've given you 4 sequences. You can always check it with the 5th one. But if you add the first, start with the smallest one. So if you add 1 and 3 together, you get 4. If you add 1 and 5 together, you get 6. If you add 3 and 5 together, you get 8, 7 and 9, you get 16. All right, so as you can see, they're all even numbers, okay? So if you add together two odd numbers, you're going to get two even numbers. If you want to add 15 and 17 together, you get 32. So you're still going to get an even number. So you can make an odd number, all right? So the sum of two odd numbers is always an even number. Okay, so let's have a look at number 7. Make a conjecture about each value or geometric relation, the product of two even numbers. So start thinking about even numbers. So you can do 2 times 2. Well, that's going to give you 4. Okay, 2 times 4 is going to give you 8. 4 times 8 is going to give you 32. Let's just do 6 times 10 is going to give you 60. All right. Well, let's have a look at these numbers, which are your answers. What do you get? Well, the obvious one, and look for the obvious one. If you multiply two numbers together, your answer is always going to be even. And it's as simple as that. Don't try and make anything bigger than what it is. All right, so now we're moving on to example 3. Making conjectures from data instead of having rows of numbers or shapes. This time you've got a table of values. It's talking about the number of customers in a restaurant on the weekend. So as you can see, you've got the days, from Friday to Sunday, and the total, and the months 1 through 6. The first thing to do is make yourself a diagram, a graph, and plot them. And as you can see from the diagram they've done things color coordinated. It's so much easier to see visual things. Okay, and from that you can make conjectures. All right, so if you look at, for a start instance, red is Friday. There are far less customers on a Friday than there is on Saturday and Sunday. Well, if you look at the Saturday and Sundays, they are very close together. So that's telling you that you need more people on Saturday and Sunday than you do on Friday. Okay, so let's have a look at this from what you've got. All right. For this, you'd be probably better to use graph paper. So bring over graph paper. I'm just going to do mine freehand. Okay. Basically, what you're looking at is a line chart. So draw your graph. Okay. What do you need? Your years are going to go at the bottom. So 2010, 2010, 11, 2011, etc. All the way down here to 15. So 2015, and then obviously you're going to do your millions going up. So probably do it in 50 millions, all right, 50, 100, etc., 150. And then you need to graph these points. And what you should have is a straight line graph with obviously points of various areas, okay? And then to find, so that's basically what you need to do for 11A. 11B says make a conjecture about 2018. So you need to extend this out to 2018. And then you need a line. Your graph will obviously continue up here, so you will go up to your graph and you'll read across whatever this is here, okay? And this is what you are after. So look for what the value is at that. You're going to get it close. Obviously, if you're going up in 50,000, you're not going to get an exact answer, but just get as close as you can. All right, so now, example 4, counter-examples. This is where somebody has answered a question and you just need to prove it incorrect, okay? Mathematically, it's easier to prove something incorrect than it is to prove that it is correct. So what we're trying to do is, if you look at A, it's asking for a real number, so don't forget negative, 0, or positive numbers, where if you square it, it's greater than n. Well, any negative number disappears because obviously when you square a negative number, it's going to become positive, apart from 1, and 1, whether it's negative 1 or positive 1. So if n is positive or negative 1, that is not, if I square that, it's actually going to equal 1, because obviously negative 1 squared is still 1. 1 squared is still 1. But the question says, or the statement says, that n squared is greater than n, which in this case, so this is your counter example, and that's all the proof that you need. All right, so now we're looking at a counter example. So this is question number 12, and question number 12 says, if angle A and angle B are complementary, in other words, two angles added together make 90 degrees, then they share a common side. Well, okay, well, let's think of a right-angled triangle. All right, if we put a 45, 45 in there, then that is two complementary, or two angles that are complementary. But then think about it slightly different. Let's think of the y equals x. Okay, so this is the graph of y equals x, so that's where y equals x. Well, this angle here is actually vertical to that, and they are both 45 degrees. All right, so this is 45 degrees, and so is this guy here. But they do not share a common side, but the two of them added together do make 90 degrees. So that's the easiest way of proving that false.